Hi, everybody. My name's Dave. I'm a developer advocate. I work at Google. I work on the IoT platforms team. I focus primarily on a platform called Android Things, which I'm going to talk to you about a little bit today. But I want to talk a little bit broader in terms of that. We're going to talk about kind of all of the Google technologies that we currently have that help enable IoT applications in a variety of different capacities. So we'll kind of get started here and we'll kind of look at the whole picture as sort of a holistic element here. So just quick show of hands, how many of you have heard of IoT before? Okay, all right, that's good. Keep them up for a second, just a second, keep them up for me, there we go. How many of you with your hands up right now would be willing to come up on stage and give a definition of what that means? Hey, look, all the hands go down, right? So IoT is kind of an amorphous concept, right? Like we've all heard about it, it's a very popular buzzword. Those of you who raised your hands probably know that it stands for Internet of Things, but what does that really mean? It depends on who you talk to. Right? Like I think the sort of the bare bones definition that we're going to be working with as I talk about some of these things today is just smart connected devices. Right? I think it's straightforward enough and all-encompassing enough that I think it will fit most of the definitions and use cases you probably have heard of before. Right? So these are just building devices that are smart in some capacity, meaning they have some amount of application processing capability. We can program these things to do certain tasks, whatever we need for our application, and connected in some way. Now, connected to what? Again, depends on who you talk to. Right? We can build IoT devices that connect directly to the open web, to the cloud, to the internet. Or we can build IoT solutions where devices actually connect to each other and form smaller local networks of some kind. Okay? So there are various definitions of what those things might actually mean, but at the end of the day, you're building a physical device of some kind that is smart and connected to something. Okay? And so for most of the folks in the room, let me just kind of get a show of hands. How many of you are software developers? How many of you are Android developers? Okay, about half. All right. So for those of us in the room who are familiar with doing software development, this is a slightly new paradigm, if for no other reason than we're actually talking about building a real thing now. So we're not just talking about the software that you can write to run on these types of devices. We're actually talking about trying to enable you to build the devices themselves. Right? So we're talking about doing electronics, mechanical engineering, things like that to actually build a functional thing that you can ship to consumers or sell into the enterprise or whatever your use case may be. So we'll talk a little bit about kind of some of the things we're trying to do to help make that easier, especially for software developers where hardware might be somewhat of a scary concept in some cases. But in general, an IoT type solution really has sort of three layers to it, right? You've got the actual physical hardware that this is running on, the device or the thing. And then you've got some amount of software that's running on that device. You've got an operating system, you've got an application or two or three or whatever running on that device, interacting probably mostly with the hardware, but then also maybe with some connectivity. And then you've got sort of the back end or the cloud integration, right? You've got the connected element that device is actually interacting with. It might be a cloud service. It might be a gateway device that some of these devices are connecting to locally, but there's some amount of connectivity going on in this whole level here. So these are kind of the three areas that I want to focus on describing from our perspective sort of the pieces that Google is hoping to provide to help make this a little bit simpler, a little bit more straightforward. And as I mentioned before, I work on the Android Things platform primarily. So Android Things really sorts of fits in the middle there. So when I talk about that platform in specific, we're talking about kind of the device software or the operating system and the applications that are running on the actual device. Okay? But we're going to start from the bottom and work our way up. So the first thing I want to talk about is I want to talk about hardware a little bit. So if you're familiar with Android Things at all, or you've looked at our documentation or seen any of our other resources, you've probably heard us use this phrase before, this idea of prototype to production. And really, when it comes to our hardware story, a lot of the things that we're focusing on inside of Android Things is enabling developers to easily build physical prototypes, but also take those prototypes and quickly and easily turn them into real production devices that they can ship and maintain at scale. Okay? And there are software solutions as part of that, but there are also hardware solutions as part of that. So I want to start talking about the hardware. So again, what is Android Things? How does it fit into this IoT idea, right? Basically what we're providing here is we're providing a solution that enables developers to easily build applications running on these physical things that you're going to build. So as a starter, we support a number of hardware platforms that enable you to do some of this prototyping work. Just curious, how many of you recognize the board on the right? My right, your left, sorry. That is a Raspberry Pi. Okay? If you hadn't recognized the board, you probably recognize the name, right? So Raspberry Pi is a very popular platform for developing applications and playing around with building embedded hardware, embedded software, because it's very inexpensive, they're easy to get, and it's a very popular platform to work with, right? If you've never done any development with one of these before, you can very easily write application software that runs on this board, but there's also this series of pins up there at the top that enable you to connect other things. So I can connect sensors, I can connect motors, I can connect all this different type of I/O devices, and then I can interact with those things directly from the code that I write. So I can read data from the sensors, I can control things physically using all of that I/O. Okay? So the Raspberry Pi is a very popular prototyping platform, and it's one of the platforms that we support with Android Things. So as a developer, you could, if you already have one of these, which many folks already do, or if you'd be interested in purchasing one of these, you can use that platform, you can flash the Android Things operating system onto that, and then you can use it as a prototyping platform for building your first idea or your proof of concept or your first application. Okay? One of the things about the Raspberry Pi, though, is it works very, very well as a prototyping platform, but it's difficult to productionize. If you build a concept or an idea around a Raspberry Pi, it's hard to buy thousands of those or hundreds of thousands of those, and you certainly don't necessarily get a price break in the quantity that you buy. Okay? So it works really well as an educational tool, as a prototyping tool, but it's not really designed to scale up into a final product. So one of the other hardware platforms that we support that is intended to solve this solution is the one sitting on the other side there, which if you stand far enough away, almost looks like it might also be a Raspberry Pi. And that's actually on purpose. But what I'll show you here in just a minute is that's actually a composition of two boards stuck together that we call a developer kit. And this developer kit is specifically made by NXP. It's called the Pico. And this is a platform that we also support with Android Things, but is designed in a more of a production-focused way. And so I want to talk a little bit more about that because it's a paradigm that you'll see in most of the hardware we support, as opposed to platforms like Raspberry Pi, which we encourage to sort of help you get started, but not necessarily to take into a full-scale production. So if I actually explode this out a little bit, one of the things that you can see here is that this piece of hardware that we support is actually two pieces. It's this tiny little module that you can see broken down there at the bottom that we call a core module or a system-on module. There's a number of different names for it. But that little module is the piece that is actually running the operating system in your code. That has the CPU, the memory, the storage, the Wi-Fi and Bluetooth. All of those interfaces are on that tiny little module. And then as part of the developer kit, we just stick that on top of a larger board that makes it look exactly like a Raspberry Pi. Well, why do we do that? Right? So during development, that means that you have the same ease of interaction as you would with a Raspberry Pi for prototyping your idea. You can easily connect your sensors and your motors and all of that. If there are peripherals that you have already that are supported by the Raspberry Pi, we use the same pinout on that developer kit so that you can use them on this hardware as well. So it also facilitates sort of an easier way of getting started. However, at some point, you're going to want to build that idea that you have as a working prototype into a real production product. And at that point, you're going to essentially want to discard the developer kit, and you'll probably build your own custom baseboard that has just your sensors on it or just the I/O associated with your actual product, molded and shaped to fit in the enclosure that you actually want to build. In that case, we provide the core module as a component that you can integrate into your final design. So the reason that it's so small, it's about 3/4 of an inch square. The reason that that design is so small is that it's very easy to integrate into whatever your final design ends up being. And it means that you can buy all of the hard, crazy electronic stuff as a component rather than having to redesign all of that yourself from scratch, especially if you don't know an electrical engineer or don't have an electrical engineering background in your company. I'm going to talk about this in a minute, but the electronics on that particular core module are a little bit complicated to build, right? The electronics that you would need to put on some sort of a baseboard in terms of integrating specific sensors or basic I/O is much, much simpler. It's the level of electronics that you could learn how to do with tutorials online, as opposed to the electronics on that core module, which generally you're looking at a master's degree in electrical engineering to put that together. And I'm going to show you why in just a minute. So we think that this helps facilitate this idea of helping you build production devices, because you can take that core module and you can take it right off of the developer kit and integrate it into your own custom product design. This is an example of something that we built for Google I/O last year. This is what we call the Edison candle. And the reason for that is that at the time it was using the Intel Edison core module to show off this idea. So Intel Edison is another module that has a similar form factor, although we don't support it anymore because Intel deprecated it earlier this year. But you get the same idea, where that tiny little blue module is the part that's actually running all of the operating system and everything else. And we can stick it onto just another custom board that has power and integrates with a couple of I/O. In this case, it was integrating with a couple of LEDs, and it just used some software to blink them like one of those LED candles that you would buy, off the shelf. Okay, so a little bit of an overpowered application for a dual-core x86 chip, but at the same time, it was a good example of kind of showing you how you could integrate these things into your own custom hardware. Okay, so we support hardware solutions with Android Things that follow this form factor in general, so that you can do the least amount of hardware development necessary in order to get a working product, right? There's still some amount of electronic design involved, but it's only for the I/O part of the system, the pieces that are specific to your application. All of the core electronics pieces that go into the compute module, you just buy those things, right? And they're designed to be bought in single quantity, hundreds, thousands, tens of thousands, right? So that you can purchase those and actually build them into a real scalable product that you ship out to consumers. Okay. All right. So why is this really a big deal? And I think it goes back to this idea that certainly for software developers, the idea of developing hardware can be a little bit off-putting, right? It's a skill we don't have or are not terribly familiar with. And in general, it turns out developing actual hardware is a difficult thing to do. Right? Whether it's just because you have to deal with producing physical things, and so it's not just recompile your code. When you make a change, you need to delete the line and recompile again. You have to actually build new boards when you want to make a change and things like that. But there's actually a lot of complexity inherent in some of these core electronics. And I want to point out something on this. This is actually a zoomed in view of the Raspberry Pi, and it's a zoomed in view of the core processor that's on that chip. And if you look in sort of the bottom corner there near where the HDMI is written into the silkscreen there, you can see a bunch of squiggly lines. And those squiggly lines are wires. They're what we call traces. They're just connections from that processor off to other components on the board. But it turns out they're squiggly for a reason. And it's a very complicated reason. Right? So the pieces of electronics on this board are very high frequency. They run at very high speed. And it turns out when you're exchanging signals at a very high frequency, those traces have to be a very specific length. And if you have more than one wire on a bus, they all have to be exactly the same length. And if they aren't, really bad things happen. Right? You get issues like resonance and stuff in the various frequencies that cause noise and interference, totally destroys the signal. So it turns out that when you're interacting with building high-speed electronics, it is actually hard to do, okay? And it's hard to do right. And so we want to avoid forcing developers to do these kinds of things when you're building a physical device for the IoT. Okay? So that's really the core idea behind the core module, is all that crazy high-speed hard stuff is on the module. So, and the electronics that you have to design as part of that interface I/O, those are what we would call low-speed interfaces, which don't have these kinds of restrictions, right? You can just connect these wires kind of however looks good to you in your design. There's a few rules still involved, but it's a much simpler process, so it requires a much lower level of electronics knowledge to be able to complete it successfully, okay? So these modules are they take away the hard part of electronics. They're also easy to purchase in high volume for scale. Okay? There's one other piece that I want to talk about the modules, and that's testing. So the other thing that a software developer might not necessarily think about when it comes to building a real physical product is when you ship something to a consumer or to even an enterprise if you're doing B2B type of work, that device that you build has to be certified for various types of safety testing, FCC testing here in the US anyway for all of the wireless interfaces. And if a product isn't certified, you can't sell it. You can't ship it to whoever those consumers are. This process is expensive and it's also time consuming. It takes a lot of time to spin up a testing lab, to give them hardware for them to validate all of these things like that you have the appropriate transmit power on your Wi-Fi radio and all of that stuff, right? That your power supply isn't drawing too much and would cause someone's house to catch on fire, right? So these are they're complicated tests and they're expensive. The reason that core modules help you here is that if the bulk of your system is built onto one of these modules, all of these modules are already pre-certified for all of those regulatory and safety agencies across, various agencies across the globe, things in the EU, Asia, and the US. Okay? So it doesn't mean that it eliminates your need to test your final product, but it greatly reduces how much testing you have to put in. If all of the complicated electronics are on the module, including all of the wireless stuff, then your final design becomes very simple to test. You still have to contact a testing lab, and you still probably have to provide them samples of your hardware, but you also provide them the certificate from NXP or Intel or whoever made the core module that says this component is already certified. And then the amount of testing they have to do for the additional pieces is significantly less. And in a lot of cases might be eliminated, like in the case of Wi-Fi, because it's all on the module already. You're not making any changes to that system at all. Okay? So it helps you reduce the cost and time to market in terms of having to go through regulatory testing because the modules handle all of that for you. Okay? So there's a lot hidden in that little core module idea that we support with Android Things. Okay. So that's kind of the general idea around the hardware that we support. Let's talk a little bit and move up a layer now in terms of the software. So talking a little bit more about Android Things as a platform, as the operating system that's running on these devices and why that helps you as developers. Okay? So about half of you mentioned when I asked you to raise your hands earlier that you were already Android developers. So Android Things, just as a general overview, is a variant of Android very similar to Android Wear or Android TV or Android Auto that is basically just running the Android platform on a new form factor of devices. Okay, so those of you who are already Android developers, you can build applications for an Android Things device using the same SDK and the same tooling that you're already familiar with. Okay? Those of you who aren't Android developers, you can, again, build applications using the Android SDK and those Android tools, which are very feature-rich and very easy to learn. Okay? So it gives application developers a rich platform on which you can build these applications using the Android Studio IDE, which has fully featured debugging, deployment capabilities, profilers. There are a bunch of new profilers that just came out in Android Studio 3.0 that really enable you to not only build an application easily using the Android SDK, but really make sure that that application is performant, that you can find problems easily. Just curious, does anybody in here have any experience doing embedded software development outside of Android? Okay, so those of you who have done that are probably familiar with how bad this can be in embedded, right? There are a lot of systems out there, both in just the connectivity between the devices and the host machine, but also just sort of the lack of unification in the tooling required to do basic things like debugging your code on the device. Okay? And when you're running an application or a system like Android Things, you're able to do all of that stuff using the same tooling that you do to debug and develop your Android apps. Okay, so connecting the device to your machine is done using ADB, the same debug bridge that you use to connect an Android phone. So all of that is seamless and easy, and we leverage all of the maturity that those tools already have for application developers who are building mobile apps today. One of the other big advantages is that Android Things is running a variant of Google Play Services. So again, those of you who are Android developers probably already know what that means, but the idea here is that there are additional APIs provided from Google that enable you to do more complex things on Android devices. These are outside of the core Android SDK. These are things like the Mobile Vision API, some enhanced location APIs, and things along those lines. Okay. So we support Google Play Services on all of the Android Things devices that we support. And this is actually kind of an important thing because Android as a whole, Android proper, has been a popular operating system for use and embedded for actually a very long time. And the reason for that is because Android is open source. So the open source version of Android has been taken by many hardware manufacturers over the years and ported to specific platforms so that they could use it in an embedded application. Okay? The problem with that, well, there's a couple problems, and we'll talk about a few of them over the rest of this talk. But specifically, the problem here is that the open source version of Android doesn't have all of the same APIs that Android developers are used to using on consumer Android devices. And one of those is Google Play Services. Play Services is a closed source set of APIs that is provided by Google only on Google certified hardware. And so when you take Android and you build your own version of it from open source, you're not going to get all of those API support that is available to other Android developers that happen to be building on mobile phones. Now that Android Things exists and is a platform that is supported by Google on these pieces of hardware, now we are providing Play Services with the SDK the same way you would get on a mobile phone or a tablet or any of those other supported platforms. Okay, so as a developer, it means you get access to all of those Google APIs as well as just the core SDK. That means that you get to use all your other favorite APIs like cloud services, so things like the Google Cloud Platform, Firebase, and I'm going to talk about a few of those as well a little bit later. Okay? So as a developer, it's a very feature-rich SDK and set of APIs that you have available to you to build these applications. Okay? Full UI toolkit, multimedia APIs, camera APIs, all the stuff you use today on Android. It all works on Android Things. Okay? All right. So Android Things is a variant of Android though, so it's a little bit different than the version of Android that's running on your mobile phone. And so I want to talk briefly about what those differences are. So some of you may have seen a diagram like this before. This is essentially just a stack diagram of the overall Android operating system. Okay, you've got the Linux kernel underneath, some lower level software services and things like that. And that application framework layer, that's the layer that you as developers typically touch. Right? This is where the system services that you interact with in your apps for location, multimedia, camera, all of those live in there. Right? And then on top of that, we have sort of the core built-in applications that you would typically find on your device. So a launcher app, a phone app, a browser app, even some system services like Bluetooth and NFC are implemented as apps. Okay? So all of that pieces live on top of the framework, and when you have a mobile phone, all this stuff is essentially available to you and available to the user. In Android Things, we're a bit more focused on building an embedded IoT single function type of device. Okay? So the Android Things stack looks a little bit more like this. Okay? All of those core applications are gone. Okay? When you're building an application for Android Things, there is no default launcher app for the user to jump in and pick whatever app they want to launch. Right? There's no browser, there's no phone, there's none of that stuff. Okay? The only app running on an Android Things device is your app. Okay? And we've designed the system in such a way that your application, using some tricks in the manifest, which we probably won't go into details today, enables you to tell the system that this app needs to be launched automatically on boot, similar to the way the launcher would be on a mobile phone. Okay? So you're really building a system where you're writing a typical Android application, but it's an Android application that is launched automatically by the system so that it's always running. Okay? So you kind of become the one foreground app in the system with no other apps to compete for your attention. okay, or for the user's attention per se. We've also modified the framework a little bit. I mentioned before that basically all of the Android SDK is available to you as a developer, and for the most part that's true. What we have pulled out are a few of the APIs that either don't make sense on an embedded device or don't make sense on a device where there's not multiple applications from multiple sources, right? So one example is like all the system content providers don't exist on Android things. There's no contacts provider, no calendar provider, voicemail provider, things like that. Because there is no reason for a shared federated provider of user data across multiple apps that aren't built by the same source, okay? So some of those APIs are not necessarily there. The notification API, for example, exists but doesn't really do anything because there's no system UI visible on the display, even if you have a display, to actually show that notification. Okay, so there are some minor changes based on the specific use case, but in general the APIs work the same. Probably one of the biggest ones, and this will only really ring true for those of you who are Android developers, but one of the biggest ones that you'll find is runtime permissions is disabled. Okay, so on an Android device, if you build an Android app for a user's device, typically there are various permissions that we call dangerous permissions that a developer has to ask the user for permission to do a certain thing by showing them a visible dialog. These are things like using the camera, getting device location, things like that. And that dialog is managed by the system. So if I want a location API, I need to ask for that permission first. System shows a dialog, user says okay, and then so on and so forth. There's a couple of reasons why that doesn't work on Android things. First of all, we don't always have a display. We don't require you to build a device that has a display connected, even though we support it. So we can't guarantee that that dialog could even be shown or that there would be anyone there to interact with it, right? So there's a technical limitation there, but there's also kind of this conceptual idea, again, that the only apps running on this device are the apps owned by the developer who built the device. Like there's no app store, there's not users picking apps and installing them on the device separately. So since you have full control over the device and all of the data on it, the idea of an application accessing shared data that came from another application isn't really relevant. So we've disabled all that functionality. Those permissions still exist because you have to request them to use certain APIs. But they're granted automatically at install time, the same way that they used to be granted prior to Android M. Okay? So there's a couple variations there in how Android things works to typical Android, but overall generally the same. And then what we've done is we've added new APIs to enable building these applications that are more tightly coupled to the hardware. Okay, so we've added additional APIs, and I'm going to talk about a few of them in more detail that enable applications to do more lower level type of device management, interacting with the Bluetooth in a more detailed way than a typical application would, and then these things that we call peripheral I/O and user drivers, and I'm going to talk about those in a little bit more detail right now, as it turns out. So peripheral I/O is essentially a set of APIs that enables you as an application developer to interact with those pins that I showed you on those developer boards a little bit on an earlier slide, right? So those pins that you would connect to real physical hardware, whether it's sensors, motors, or other types of actuators, things like that, those interact using a series of industry standard buses that we call these peripheral I/O buses. So these are GPIO, PWM, I2C, SPI, UART, those types of things, right? Some of you may already know what those are. I can see some people nodding their heads. Some of you may look at that and that's just a bunch of alphabet soup. And that's okay for now as well. Right? The basic idea is these are all standard interfaces that peripheral devices typically communicate with. And we're adding APIs to the system that enable you to interact with those physical devices directly from your Android application using Java APIs, or if you want to use Kotlin, it works there as well. Interacting using the same system service type of API that you would use for any other Android system service as part of the SDK. Okay? This allows you to interact with those physical devices like sensors and motors and things like that. But in some cases, there's a better experience that we can provide to the application developer or to the system as a whole by actually integrating the data from that hardware back into the framework. So peripheral I/O is really about us enabling you to communicate with a device that you have connected over those various interface pins on the board or on the module. But in some cases, some of that data could be useful to the Android framework. Like if you're connecting sensors, Android already has a sensor framework. right? You can interact with sensor data on your phone with Sensor Manager. If you're connecting a location-based application and you need a custom GPS module, perhaps, Android has a location framework that understands how GPSs work, right? So you can leverage those APIs to some degree for the hardware that you are adding to your final application, okay? And that's what user drivers are effectively for, is the idea that if I'm adding a new piece of hardware, I can talk to it directly using peripheral I/O. Or I could add a user driver to that, which is an additional set of APIs that actually takes the data from that hardware and just injects it into the Android framework. And then I can use the existing Android framework APIs to interact with that instead. Right? I can use Sensor Manager, I can use Location Manager, which means I can maybe reuse old existing code that was already written for an Android device. So if I already have some code that knows how to get location updates and do whatever with my backend server, but it talks to Location Manager or maybe the fused location provider and Play services. If I use a user driver from my custom GPS module instead, all that other code is going to continue to work. Okay. In some cases, there are also benefits to doing this, because if you give if you give the framework the data from that particular hardware, Android can sometimes do some smart things with it. Like location is another good example, right? The location APIs in Android typically will report to you, specifically through Play services, they will report to you a more accurate location because it uses the GPS data and the location data from network sources and fuses them together in a more accurate way than if you were just reading the raw GPS yourself. If you take your GPS data and you feed it in through a user driver, then that more accurate location is going to be available to you through those existing APIs because that code path is the same. Okay? So there can be technical advantages to doing this, whether it's just reusing code or enabling the framework to do some of those fusion types of things that it does. It does a few of those for sensors as well. So there's some value there. One of the other things that we provide, and this is not technically part of the framework itself, these are elements that we've open sourced and they're on our GitHub page, github.com/AndroidThings, is we've done some of this work for you to help you get started. So in the cases of very common popular peripherals that you might typically find on maker sites like Adafruit or SparkFun or some of those others, we have gone through and pre-written those drivers for you. So you can include them in your application essentially the same way you would include any other Gradle dependency in your app. Okay? So you can pull down, say, a button driver or a driver for an accelerometer or a temperature sensor or things like that. And it includes the pieces in there already to, if a user driver is necessary, to add that or just to do the peripheral I/O at the low level. So for common peripherals, and these are often peripherals that come with our developer kits or that are just very popular with makers and things like that, we have pre-written those drivers and open sourced them on GitHub and also published them on JCenter so that all you really have to do is buy the peripheral, load up the dependency, and you're good to go. Okay? So there's a lot of those open sourced on our GitHub, and I'll show you a link to that at the end as well. Okay. I want to show you a little bit of code. We won't go too much into this, but this will be probably mostly interesting for those of you who are already Android developers. Because the reason for me showing you this is really just to give you an idea of how these new APIs look and behave the same way as APIs you're already used to working with in Android. Okay? So this is some source code that I pulled from that candle example that I showed you a little bit earlier that was built into the housing there. And again, that example was really just taking a couple of LEDs, blinky lights, and writing some code to animate them in a flickering pattern as if it was one of those LED candles. Okay? So it's a fairly simple example. So in this case, we're using a peripheral I/O interface called PWM. PWM stands for Pulse Width Modulation, not important. What it really means is it's an output pin that you can vary the value of between 0 and 100%. Okay? And so from your code, it enables you to, if you connect it to an LED, for example, to control the brightness. Right? So all we're really doing in this example is that candle has two PWM pins that are wired up to two LEDs, and then the code is simply being used to turn those LEDs on and off in various capacities with respect to each other to give you that kind of effect. Okay? So from the Android Things perspective, the peripheral I/O code is essentially just interacting with a new service that we call the Peripheral Manager service. and then opening connections to those various pins, whether they're GPIO, PWM, whatever, from that particular service. You pass it the name of the pin you want to connect with. It returns back to you an instance of that object that you can then configure, set up, and then in this case enable. Right? So with a PWM is basically just a square wave output. So it looks like just a big toggling wave. And so when we're configuring it, we basically have to tell it what the frequency of that output is, and the duty cycle is that value that says 0 to 100%, right? So 25 is basically on 25% of the time, which would mean I would get 25% of the output on an LED, for example, okay? So fairly straightforward code to write, right? And with just that little bit of code, you're interacting with an LED on a physical pin from your app, okay? Similar to a lot of the resources in Android, like a camera connection, for example, peripheral I/O can only be used by one process at a time. So generally speaking, when you're not interacting with that particular resource, you probably want to close that resource down. So these are all closable resources similar to other types of hardware that you would find in Android. All right, but then beyond that, we can do some really interesting things because we're running in Android now. So great, I connected to this pin and I could write some code to interact with it and set the value, and maybe I have some timers or other things to change it over various patterns. But this is Android. Android has an animation framework. And an animation framework is exactly that, right? It gives me the ability to change a value of something over time. Typically, you would think of the animation framework as enabling you to change the values of things on screen. But really, it's just animating properties on objects. So I can use Android's animation framework to animate the value of my PWM to actually get that blinky effect that I want, that flickering effect, without having to really write hardly any code at all. Okay? And so what we're actually doing here is we're creating a custom property for the animation framework in Android to animate the value of that PWM. And basically whatever the animation fraction value is, we just convert that into a duty cycle for the PWM, and then we can run animations inside of Android, and it will automatically control the value of the PWM based on the animation. Okay? So showing you kind of the rest of that code here, you get something that looks sort of like this, right? So you can create a new animator. You just have to give it a new property, in this case the one we defined for that specific PWM, and then you can use the rest of the animation framework to configure this however you like, right? You can use interpolators, which is what I did here, which actually creates sort of that flickering effect in the LED. An interpolator, if you're not familiar with it, tells the animation how to interpret over time. So it could be linear, or it could sort of accelerate in or out. The bounce interpolator basically tells the value to bounce a little bit at the end before it finishes, which works really great with an LED because it looks like it's flickering like a candle, right? So you can do all of that. You can tell it to just run, back and forth forever. And with a few lines of code and that new custom property, I'm basically animating the value of a couple of LEDs. Right, inside of the Android animation framework. No loops, no timers, no nothing, just leveraging the framework. So there's all these really high-level cool concepts that already exist in Android that you can apply to some of these lower-level hardware pieces now that you have Android things and peripheral I/O in the mix. Okay, so that's sort of the on-device software, but there's more to the story. If I were to stop there, then it's interesting, right? Great, we put Android on an embedded device and now you can write apps that run on your Raspberry Pi or something like that. But that in and of itself doesn't necessarily help us solve real problems around IoT and consumer products, right? One of the biggest issues really that we see with IoT consumer products today is a lot of them are built with, they're not built with security in mind, right? The S in IoT stands for security. And there's this concept that one of the biggest reasons for that is that a lot of these devices are shipped without the ability to publish updates. And so generally, they build this device on some version of embedded Linux that has an old kernel in it or something like that. They ship that out into the world, and then a vulnerability is discovered in that version of the kernel. And there's no way for that manufacturer to reach out and touch all of those hundreds of thousands or millions of devices they shipped to publish an update to patch that vulnerability. Okay? So the idea of maintaining these devices after you ship them is a really big part of the IoT story in general, especially the security story. So what we've also built into Android Things is not just the ability to run Android on these devices, but it's to actually manage those devices from a console that we call the Android Things console. Okay, and this enables you to do a couple of different things. Those of you who have done app development, this is conceptually similar to the Google Play console in that it's sort of your way to manage your application out in the world, but it's not quite the same as the Play Store, right? It's essentially a place where you can upload your applications, build those into system images that should be deployed down to your devices, and then publish those updates over the air, okay? So unlike with Google Play, you're not just able to update your apps. You're also able to update the version of the operating system running on those devices. These are full OTA updates, just like the ones that your OTA updates get, or that your phones get when a new version of Android comes out. Okay? It's the same mechanism even that we use to publish those OTA updates to Android phones. Right? So it enables you from this console to, when a new version of Android is available for your supported board, or the monthly security patches that we're already applying to Android today, when those patches are available, you can go to the console and you can build a new system image and you can publish that to all of your devices that are already in the field over the air. Okay? So it ensures that these devices can be updated as quickly as possible, and you're leveraging the work that Google is already doing on Android with the security work that we publish to the Android tree every month. Okay? So all that functionality can now be leveraged in the platform that you're building your application on top of to help guarantee that you're actually building a product that once it goes to scale can be maintained properly at scale. Okay? So it's not just Android running on the device. I talked about a little, some of this already, but these are kind of more of the internal bits, right? So we're leveraging a lot of the functionality inside of Android that's already built in for securing these OTA updates, right? So the over-the-air updates are signed by Google. That ensures that those images are verified on device, that they haven't been tampered with, that the device always boots into a known good state. These are all features and functionality that are already in Android devices today, and now you can leverage those on the devices you build if you build them on top of Android things. All right, the last thing I want to talk about briefly, because I'm running out of time, is connectivity, so the high level of the stack there. So there's a couple solutions that Google provides to help you actually get these devices connected. Now what I want to say about this is that this is Android. This is Android running on an embedded device. So technically speaking, you can interact with whatever backend cloud service you like, perhaps even the same one or in the same way as the way you interact with backend services on your Android device. Okay? But there are a couple services offerings that we have at Google that fit very well with IoT solutions, and so those are the ones I'm going to talk about here. So the first one I want to mention is something called Cloud IoT Core. Cloud IoT Core is currently in public beta. It's a very new product. We announced it at Google I/O this last year, and it just went into public beta maybe 2 months ago, something like that. This is essentially, it's a bridge, or it's an interface that enables you to get data off of IoT devices and very efficiently and securely publish that data into the Google Cloud ecosystem. Okay, so Cloud IoT Core really at its core enables you to take data from IoT devices and publish them into a Google Cloud project using PubSub. That's kind of the way that it functions today. And then from there, you can ingest that data using all the existing APIs that are part of Google Cloud, right? You can use Cloud Dataflow, Data Studio, BigQuery, all of these other things to ingest that data, analyze it, do whatever you want to at that point, right? So there's a lot of tools already available in Google Cloud for very high-level complex data processing. But what was missing was this sort of easy, secure way to get data from thousands or millions of devices into that Google Cloud project. Okay? And that's really what Cloud IoT Core is about. It's two primary elements. The first is the protocol bridge, which basically, again, enables you to funnel that data from IoT devices using protocols that might not otherwise be supported except in IoT, like MQTT. Right? MQTT is a very popular protocol in IoT for publishing messages from small IoT devices, like microcontroller-style IoT devices. With Cloud IoT Core, you can now publish using MQTT directly into Google Cloud. Okay? Or from a higher level device, you can also use HTTP if that works better for the application. But it's really about enabling that large fan-in of devices to publish that data into your project through PubSub. And then on the other side of it is the secure device manager. So devices are registered with a cloud IoT project using standard public-private key authentication, right? The idea that the device has a private key on it, and that public certificate is published to Google Cloud through the device manager to create a secure channel over which you can do these things like MQTT and ensure that those specific devices are registered to that cloud project. Okay, so the additions of Cloud IoT Core to the overall cloud family are really about enabling all of these disparate devices now to publish their data into the rest of the ecosystem that already exists. Okay, and then quickly I want to mention a couple others, which is I have sort of a sample application here to help you kind of think of how you might use Firebase in IoT. Okay, so who's familiar with Firebase? Okay, so those of you who are not, Firebase is a large suite of cloud-based and app-based services that enable you to build, primarily focused on mobile, but enable you to build applications that interact with various backend services. And because Firebase works so well on Android, it's extremely easy to integrate on Android things. Okay, because the exact same client libraries that you use for your Android apps, you can use those to do client-side functionality on Android things as well. Okay. So what I've got here is a very basic system where you can leverage various pieces of Firebase inside of an Android Things application. So this is like think of it as a smart home application. Like I have a device that controls my lights. I've got a companion app that I use to register that device and send commands to it and all of those things, right? So you can use APIs like Firebase Authentication, for example, to get your devices online and get them associated with a user's account. Right? These are APIs that you can do that today for your mobile app, but you can now authenticate an IoT device the exact same way. Now there's a couple differences there because if your IoT device doesn't have a display, you can't use the Google sign-in APIs to get the username and password. But you can do that from a companion app. You can exchange those credentials to an IoT device, say over nearby, for example. And then you can use those same Firebase APIs to authenticate your IoT devices using Android Things. Okay, and using Firebase. You can also use functionality like Firebase Functions, Cloud Functions, to interact with other external services like the Google Assistant. Right? So the Google Assistant has a smart home interface that enables you to build these cloud-based functions to interact with your IoT cloud with the Google Assistant so that you can talk to your Google Home or the Assistant on your phone and basically say, hey, turn on my lights. Or those types of home control, device control functionality. These are the same types of APIs that are being used by Nest and the other higher level IoT-based companies that enable you to control your devices from your Google Home. Okay? So the smart home interface, you can use Firebase Functions to interact with those callbacks coming from smart home and then just feed that into your larger device flow. Like in this example, we use real-time database. So real-time database is a very easy to use synchronization mechanism for device state. Right? It enables you to interact with, from the cloud as well as on a device, instantly synchronizing state around things like are the lights on or off, is the device online or offline, things like that. And changes made on either side are instantly reflected back and forth. Right? So you can use this as sort of like a common repository of all of the state of all these various devices, and then you can interact with that externally through Cloud Functions or other things to provide that state to things like smart home. Right? So there's a lot of these various APIs in Firebase, things like real-time database, authentication, and Firebase Functions that enable you to, with very little code, in some cases no code on the server side, basically build your own IoT cloud for some of these smart home focused or other types of use cases there. One of the other Firebase APIs that's pretty common is cloud messaging. And so you can kind of think of this in a very similar system to the real-time database, but using Firebase Cloud Messaging instead of real-time database, you can actually send messages down to the device that will be queued for delivery. If you have an application where you don't just need to know about the final state, you need to know about all the individual messages that happened while that device might have been offline. Okay? All right, so wrapping up. So we've got device hardware, the embedded software, and the cloud integration there. And as I mentioned, the IoT group and primarily the Android Things group is focused on enabling developers to build at all of these layers, right? So we're working with hardware partners to provide hardware platforms that enable you to build devices easily. We provide Android Things as a platform to easily build the application software running on those devices. And Google, as a larger group, provides cloud services that are easy to integrate on Android. So you can also easily integrate those on Android Things inside of your IoT devices, things like the Assistant, Firebase, and Cloud IoT. Okay? All right, so just a couple final links there for if you want more information. The documentation on it is on the Android developer site, so developer.android.com/things. Our Android Things samples and those pre-written drivers that I mentioned earlier are on GitHub, so that's github.com/AndroidThings. We have a public community on Hackster.io where a lot of developers who are using Android Things have published projects that they've been working on. We actually just finished running a contest for developers using Android Things on Hackster, so there's a ton of crazy projects that people have posted to do all kinds of things. It kind of give you an idea of what people are already using Android Things to do, maybe get you inspired to do some things yourself. And then we also have a community on G+ for all of Google's IoT technologies. So myself, a lot of the other folks on the IoT teams are on this community answering questions. It's a great place to give feedback, ask other developers if they've had similar issues, if you're running into problems, or just share your projects, things like that. Okay? So, as I said, I'm Dave. Thank you very much for your time today, and I hope you enjoy the rest of the conference.